In this lesson, we are going to discuss about the relational model. The relational model is the primary data model for modern commercial data processing applications. And at the heart of the relational model is the concept of a relation, or in simple words, a table. A relational database is a collection of such relations or tables, and each of them are assigned a unique name. A table looks something like what you see here. In this instructors table, we have captured the information about a set of instructors working in a university. And you can see that this table looks pretty much like a normal table that we are familiar with. In general, a row in a table represents a relationship among set of values, and it describes a single entity. The relational data model takes its name from the fact that a table is a collection of such relationships. And in our example table, we can see 4 columns: ID, name, department name, and salary. And each row in this table represents a single instructor. So in a single row, different columns describe different properties about a particular instructor. There are some terminology we have to be familiar with when we discuss about the relational model. We learned that another name for a table is a relation. And we use the term tuple to refer to a row in a table. Similarly, the term attribute refers to a column of a table. We will use these terms interchangeably throughout this course, and you should be familiar with them. For each attribute of a relation, there is a set of permitted values, and we call that as the domain of that attribute. For example, the domain of the salary attribute in our instructor relation is the set of all possible salary values, which is probably any positive real number. And the domain of the name attribute is a set of all possible instructor names. And each column of a table must have a unique name. We can't have 2 columns with the same name in the same table. But across multiple tables, we may have the same name in 2 different tables. That is okay. And each attribute must contain a single value. So I have this students table here where there are multiple numbers listed under the phones attribute. So for one particular row, you can see there are some rows have 2 records for the phones and some records have only 1 record. And that is not allowed in the relational model. If you wanted to have multiple phone numbers for a given student, you would either need to have separate columns like phone 1, phone 2, phone 3, so on. Or there's an alternative approach that we will learn later in this course. So for now, let's remember that for one attribute, we can only have one single value. Now, when it comes to describing a relation, we specify what's known as its schema. It's a simple notation and that consists of the name of the relation, the names of its attributes, and in some cases, we also include the possible values or the domains of each attribute. But most of the time, we just omit that and we only specify the relation name and its attribute. For example, if we take this student table here, this is how we specify the schema. Student, the name of the table, and within brackets we specify the attributes ID, name, and phone separated by commas. So that's how we can specify the schema. In relational model, we must have a way to distinguish each tuple in a relation. That means attribute values of a tuple must be in a way that we can uniquely identify the tuple. No two tuples in a relation should have exactly the same values for all attributes. A superkey is a set of one or more attributes that, when taken collectively, allow us to uniquely identify a tuple in the relation. For example, in our instructor table, we have the ID attribute and each instructor has a unique ID. So ID is a superkey for the instructor table. And there are other possible superkeys as well. For example, if we take ID and name together, we can see that they can uniquely identify each row. And even if we take ID, department name, and salary together, they form a superkey. But if we take something like the name only, we can see it is not a superkey because name alone is not enough to uniquely identify each row. And if we consider a small theory, if K is a superkey, then any superset of K is also a superkey. And if you are not sure what superset is, look at this A and B sets. So A has 1 and 2 in the set and B set contains 1, 2 and 3. So we can say A is a subset of B, or on the other way, B is a superset of A. That means B contains all the elements of A. Then A becomes a subset. And on the other way, B is a superset of A because B contains everything from A and some additional items. So if A alone can identify uniquely each row, even if we add some additional attributes into the set A, that still can uniquely identify the rows. So that's why we say if K is a superkey, then any superset of K is also a superkey. Now, we are often interested in superkeys for which no subset is also a superkey. And such minimal superkeys are called candidate keys. Simply put, that means a candidate key is a superkey with no redundant attributes. So it's the minimum superkey. Let's check our instructor table again. We have already identified a set of superkeys, and out of them ID is a candidate key for this table because it contains only one attribute. So it is a minimal key. And although ID and name together can distinguish instructor tuples, it is not a candidate key here since the attribute ID alone is sufficient to uniquely identify the tuple, and since the name attribute here is redundant. A relation may have many candidate keys, and when we define a relation in an actual database, we choose one of those candidate keys as the primary means of identifying the tuples, and that key is known as the primary key. And two tuples in a relation cannot have the same value on the primary key attributes at the same time. The designation of a primary key usually represents a constraint in the real world that is being modeled in the database. For example, if we are modeling a university environment, we may identify the index number as the primary key for the student relation, because we know that each student has a unique index number that we can use to identify each student. When choosing a primary key, we try to make sure that the attribute values are never or very rarely changed. For example, if we choose the student index number as the primary key, we know that it is very unlikely for a particular student index number to change later. We can specify the primary key of a relation in the schema notation by underlying the attribute. So you can see here in this example schema for the instructor relation, we have specified the ID attribute as underlined. So that way when someone sees this schema, he gets the idea that in this schema, the ID attribute is the primary key. Sometimes a relation may include among its attribute the primary key of another relation. And this kind of attributes are known as foreign keys. So we have an example here, our instructor table, and we have another table for department. So we can see in the instructor table, the department name column contains the names of department, which is the primary key in the second table. So that means in the first table, department name is a foreign key referring the primary key of the second department table. So this way, if we want to find the information about where the Einstein instructor works, we can see that his department name is included here as physics. So in the second table, if we look up for the physics department, we can get some more information about that department. So we learned about the basic concepts of relational models in this lesson. And most of the widely used database management systems like Oracle, MySQL, and Microsoft SQL follows the relational model.